Okay, let's do a quick video. So the idea of I want to start this here, which I did some, I did some research and looked up some stuff. I'm bad at math, so I didn't really deduce this, but what I wanted was when you win. So we have this range of trophies, right? So we have 26, all the way to 34 for. Let me look up something real quick. Clash Royale. Trophy range, win loss. Okay, never mind. That's not what I'm looking for. Trophy range, trophy delta range, I guess. Okay, never mind. This is bullshit. Anyways, we have a range here, right? When it has more bias, right, meaning more crowns, it'll be more randomly pushed towards this side. Still random, but more rewarding for getting more crowns, because if you won and have more crowns, that's that. So the bias will tell us that. The bias is calculated by how many crowns divided by 3, because there's maximum you can only get 3, and the more amount of crowns they get, the closer to they are to 1. So if they get 0, then the bias will shift towards where the randomness truly is. But if they have more crowns, the randomness will shift towards where the bias is, right? So there's that. This is for the loss. It's the same exact logic, but it inverses the effects. Meaning more crowns meaning less trophies taken away from you, meaning you're closer towards the lower edge. Less crowns, you're closer towards the max edge. But anyways, okay, so let's try that. So we have our min max range here. I need to calculate like the random values. So we do like random dot in 64, something like that. I forgot the rand in 64. Sure, there was a function like that. Why is this not? What is this? Crowns. Let me go to match store and try to fix that. Let's do in 64 and then change this as well. Here, and then we'll go back to leaderboard here. Okay, so then we'll have, is this wrong? Why is this crying? Whatever, this is probably not needed. Okay, let me get rand real quick here, right? And then we'll also have a bias, which is just I guess crowns equals match payload dot crowns. We'll do crowns divided by 3. We'll use like a flow or something. And basically the formula is basically that format, so it will be 1 minus bias times random plus bias, something like that. So that's our, actually this is not really the value, this is what x is. So that is the number basically we push our thing in, right? Then I actually don't need a max anymore. All I need is, hold on, let me save that. I think the difference here is 8, so we'll do that. Then we just basically return the int64 of, or I guess res, right? Which is just, I guess 20, the minimum plus the basically plus the x. Yeah, well, not quite. It's the minimum and how much of the minimum it is going to be affected by. Like so it's minimum plus how much of the, like, okay, so basically it's this, right? We have the difference of 8. The maximum is minimum plus 8, right? That's how we get 34 times the bias, or this bias calculation, right? So if we're closer to 1, that means we're closer to this side. If we're closer to 0, then we're closer to the minimum, because we're not gonna we're basically be adding like close something to 0, and we just return that. Same exact logic, but that's it. It's the same exact logic, but we don't have a bias, so that it flips the thing. And this time it's not 8. I think it's like 10. I think. Oh no. This is 10 first, because the range is 10, and then this is 8. Yeah. So it reduces the stuff like that. Okay. Anyways, but now I need to fix this. I don't know why this is being weird. Undefined res. Just get that out of here. Okay, so what is this? Undefined. Oh, it's not. It's math. Rand. Hold on. And then I just gotta convert this to an int64. Int64. What? Oh. Wait, what is x? Oh, let me convert this to an int first. Yeah, let's do that. So I'm multiplying by an int, so let me do int first. Then times it. Then this is still an int to int, and then convert to int64. There you go. So this is our little mini calculator. Then calc delta, and then that passes in. Then we create that. Boom, boom, boom. I'm gonna add a few more guards here. If match payload dot crowns is equal to 0, and match payload dot win, or result equals a win. Return errors dot new cannot win with 0 crowns. Game breaks. Breaking. I don't know. We'll do this. Breaking game logic cannot win with 0 crowns. And then the same thing, you can't lose with 0 as well. So we'll do another one. Breaking game logic, cannot win with 0 crowns. If the crown is 0 and it's also a loss, cannot lose. Well, that's not true. You could lose with 0 crowns. Yeah. If it's a win, no, if it's a loss, but have 3 crowns. That's my point. Cannot lose with max crowns. Maybe I'll make a constant var, or do like a const max crowns. Crowns. We'll do like 3, I guess. And then we'll just use that instead. Okay, so yeah. So, and then X is a type of Int64, yeah. Yeah, whatever. Okay, anyways, that works, and let's just commit this. Oops. Commit, or stage, and then, okay, anyways. Let's commit this. Create delta calc logic and more payload guard rails. Okay, we're good. See you guys tomorrow.